Greetings, welcome to video on problem 17. Show complete work for all parts of the problem. Right answers in exact form and in decimal form rounded to the nearest hundredth. Suppose an investment is growing at 8% per year. Determine the doubling time for this investment if the starting value is the following. Okay, so they give us the growth rate. So our growth factor is going to be 1.08. Okay, so the base on every one of these is going to be 1.08. So that tells us that the amount we're going to have at time t is going to be equal to whatever the initial amount is, and that's what we're changing or varying from one problem to the next, times 1.08 raised to the t power. Okay, so that's the model that we need for every one of them. So let's go take a look then. So for part A here, if we used $1,000 for A of t, then A of t would be equal to 1,000 times 1.08 raised to the t power. And what we're looking for is we want to know the doubling time. So what that means is we're curious, we'd like to know how much time, in other words, what is t equal to right here, right? When this value right here, A of t, is 2,000, or double what the original amount was. And that's going to be true for all of these problems. We're going to take the original amount, double it, and then determine what time it takes for it to get to there. Okay, so what you'll see then is you're going to get 2,000 is equal to 1,000 times 1.08 to the t power. Now another thing that you'll see that happens in every one of these is that when I divide out what that original amount was, or that initial amount, it's always going to make a 2 on the left hand side. In other words, divide 2,000 by 1,000 and I get 2 is equal to 1.08. And that's going to happen on every one of these, is that the left hand side is just going to turn into a 2. So we're going to kind of, shortcut in just a bit. All right, so that's a t there, excuse me, not a 2, my bad, sorry about that, raised to the t. Okay, so if we take the logarithm of both sides here, that's going to be t times logarithm of 1.08, and we get what? I think I'm going to grab this and move it way over here because I'm running out of room. That's going to be logarithm of 2 divided by logarithm of 1.08, and that's going to be equal to t. Okay, now they told us they wanted a decimal approximation for that and the exact. That's the exact answer. So let's go grab our calculator real quick and get the decimal approximation to that, and that's going to be log of 2 divided by log of 1.08. We end up with 9.006 years. So if we round it off to the nearest hundredth, so this is the tenths, this is the hundredths place here, so it'll be 9.01 years, okay? So this is going to be about 9.01 is approximately equal to t. Okay, so let's go take a look at part B here. So again, the doubling time, so we're going to go to 66,000. So 66,000 is equal to 33,000 times what, or 3,300, excuse me, not 33,000, 3,300 and 6,600 is times, 1.08 raised to the t, and we see that again when we divide this out we get 2 is equal to 1.08 raised to the t. Oh my gosh, look, it's exactly the same answer as we got last time. So we're going to end up with what? We're going to end up with log of 2 divided by what? Log of 1.08 is equal to t. And as a matter of fact, it does not matter what the initial amount is. If we're talking about doubling it, it's simply the log of 2 divided by the log of the base. So in other words, this one, if you go through all the push-up of doing it, you're going to end up again with log of 2 divided by log of 1.08. And the same thing is going to happen over here. You're going to get log of 2 divided by log of 1.08. Okay? Oh, excuse me, my things tell me the last video is ready here. Okay, so compare your answers A through D. Explain why this occurs. Well, why does this occur? Because think about doubling time. What is doubling time doing? It says take the initial amount and double it. So that means the left-hand side of the equation is always going to be equal to 2. So the left side is always equal to 2. always whenever you're doing the doubling time. As a fact, when you talk to investment bankers and people like that, they do this using exactly that. They just take the log of 2 and divide that by the log of the growth rate, and boom, they get their doubling time. And similarly, when you're doing a half-life thing, it's the log of a half divided by the log of whatever the decay rate is, and you get the same thing to do a half-life. Okay, well, hopefully that was helpful getting you going. I'm going to shut this one off and get on to the next one.